Our immune system, it's our body's ultimate protector, right? A super sophisticated army defending us from all sorts of threats 24/7. But what happens when that army makes a mistake? When it sees something totally harmless and thinks it's a deadly invader and unleashes its full, overwhelming force? Well, in this explainer, we're going to do a visual walkthrough of exactly how that happens, how our greatest protector can turn into a powerful adversary.
Okay, so what are we getting into today? Here's our game plan. First, we'll meet the body's border patrol. Then, we'll see how the immune system gets secretly primed for an attack. After that, we're going to watch the whole allergic cascade just detonate, step by step. We'll connect that cellular drama to what you actually see in a patient, and then we'll wrap up with the absolute must-do nursing actions and a quick recap to get you ready for your exams.
All right, let's dive right in. First things first, we've got to understand the battlefield. Before we can talk about the crazy overreaction, we need to be crystal clear on what hypersensitivity actually means.
So here's the key thing to get. This isn't your normal, everyday immune response. Nope. It's a massive overreaction. And it's totally individual. A peanut, for example, might be a life-threatening invader to one person and, well, just a snack to another. It's a personalized, exaggerated defense mechanism gone wrong.
Yeah, just picture it. A super well-trained security force, constantly on patrol, keeping you safe. It's got these specialized soldiers like B cells, and their whole job is to spot and take out threats, whether it's a virus from the outside or messed up cells on the inside. But with hypersensitivity, this amazing force just misidentifies the enemy.
Okay, so that begs the question, right? If this security force is so good, how in the world does it get tricked into launching this massive, mistaken attack? Well, the story doesn't start with a big explosion. It starts with a whisper. The very first, very quiet meeting with an allergen.
And listen up, because this is a huge concept for your exams. That first bee sting, or the first time someone eats a peanut, you might not see anything happen on the outside. No rash, no wheezing, nothing. But that doesn't mean nothing's happening. Inside, the immune system is wide awake and it's taking notes.
And that's because that first meet and greet is what we call the sensitization phase. It's like the immune system is building a highly specific weapon that it's going to use later. It's creating a memory, an internal wanted poster for that allergen, and getting all its forces ready for the next time it shows up.
So, the trap is set. The weapon is built. The system is primed. Now, let's see what happens when that trigger finally gets pulled. We're about to watch the step-by-step detonation of this allergic cascade.
Whoa. Okay, I know what you're thinking. This looks complicated, right? Like some crazy schematic from a spaceship. But stick with me, I promise. We're going to break this whole thing down into 4 really simple visual steps. This is the core pathophysiology you've got to understand.
So it all starts right here. The allergen, let's say it's pollen, gets into the body. And the B cells we talked about, they spot it and go, whoa, threat detected. That B cell then gets the order, and it transforms into something called a plasma cell, which is basically an antibody factory.
Now, we're not talking about just any old antibody here. The factory starts pumping out a ton of this very specific one, called immunoglobulin E, or IgE for short. Think of these guys as little heat-seeking missiles, custom-built to hunt for that one specific allergen and absolutely nothing else. So these little missiles are flying around. Where do they go? They dock onto these things called mast cells. Mast cells are another type of immune cell, and they're just packed with chemicals. And this is the priming phase we've been talking about. These mast cells are now loaded. They're basically tiny little grenades with a hair trigger, just waiting.
And boom, this is the detonation. The next time that allergen shows up, it's like the perfect key fitting into a lock. It latches onto the IgE, and that is the signal. The mast cell degranulates, which is a fancy word, but it just means it explodes, releasing this flood of chemicals, especially histamine, all over the place.
Okay, so we've just witnessed this massive chemical explosion on a microscopic level. But what does that actually look like in a real person, in a patient you're caring for? Let's connect the cells to the clinic.
Right, so what's the big deal? What does this flood of histamine and other chemicals actually do as it surges through the body? Why is it so incredibly dangerous?
Well, here's what it does. It's just widespread fallout. Those chemical mediators are like little agents of chaos running wild through the entire body. They have 2 main missions. make blood vessels super leaky, and clamp down hard on smooth muscles, like the ones in your airways. And that 1-2 punch is what creates all the symptoms we're about to see.
So when you look at your patient, this is how it all connects. In the airway, that muscle clamping down gives you that scary, high-pitched stridor and wheezing. Those leaky blood vessels, that's what causes blood pressure to just plummet, that's hypotension, and it causes all that swelling, what we call angioedema. And that feeling of impending doom, that's real. That's a huge neurologic red flag you have to recognize.
Look, knowing the why behind all this is super important. But when things go sideways, knowing what to do and what to do first, well, that's what saves a life. So let's walk through the absolute priorities.
And this right here, this is rule number 1. Always, always be prepared. Anaphylaxis isn't just something that happens from a bee sting out in the wild. It can happen right there in the clinic, during something as routine as an allergy test.
Okay, so this is your action plan, and the order is absolutely critical. First, airway, always. Can they breathe? Then you call for help, immediately. You can't handle this alone. Next, get oxygen on them to support their breathing, and then you get ready with your meds. Epinephrine is your #1 hero here. It tightens up those leaky blood vessels to bring the pressure back up, and it opens up the airways. You have to know this sequence cold.
All right, let's do a super quick lightning round recap of that whole cascade. We're going to lock this in so you're ready for any exam question that comes your way.
Just burn this 6-step flow into your brain. It starts with sensitization, that first exposure. Then IgE production. The B cells make the missiles. Then mast cell binding. Those missiles arm the grenades. Then re-exposure. The bad guy comes back. That leads to degranulation. Kaboom! The mast cells explode. And finally, the systemic effects, the body-wide crisis. You see how it flows? One thing leads directly to the next.
And really, that's the whole point. Understanding this pathway, it's not just about passing a test. It changes you from someone who's just watching symptoms happen to someone who understands the chain reaction and knows exactly where and how to break it. You become an interventionist. So, what other complex pathways should we map out together next?